Hello children, I am here with second part of this chapter, classification of elements and periodicity in properties. In this part we will discuss about periodic properties. First property is atomic radii. Okay, you all know what is atomic radii. That is the distance of the nucleus and the last shell. Whatever is the distance between nucleus and the last shell, that distance is called radius. So this will determine the size of the atom. Okay, this atomic radius or the distance between nucleus and valence shell will give you the radius or the size of atom. So let's discuss how many types of radius are there. Okay, first is atomic or crystal or metallic radius. When the two atoms are combining and then they are touching the boundary or valence shell of each other, then the distance between first metal and the second metal, or you can say the radius of first metal and first atom and second atom of the metal, this radius will give you atomic or crystal or metallic radius. This distance is atomic, crystal or metallic radius. You can say that bond length means this distance r is equal to distance between m1 and m2 upon 2. Okay, this will give you the bond length. Second type of radius is covalent. When covalent compound is forming, then you can say there will be sharing of electron, and this sharing is, you can say, it is overlapping of atoms. Okay, so here this distance is the bond length. Okay, and you all know covalent bond is formed between non-metal and metal. So one radius will be of metal and another will be of non-metal. Okay, so here bond length or radius is equal to, you can write bond length or radius is equal to distance between metal and non-metal upon 2. This will give you the covalent radius. Okay, this is covalent radius. Third is Vander Waal radius. Vander Waal radius. See children, here Vander Waal is not the bond formation. It is only the force of attraction between the molecules. This is Vander Waal radius. Okay, this is the distance between two atoms of a molecule, and this is only attraction. It is not bond formation. You can say that no sharing of electron is taking place here. And this attraction will be there when the two atoms are very near to each other, but they are not touching the boundaries. Okay, or you can say closest approach. This is mainly present in noble gases. Okay, because noble gases are not able to share the electron because their octet is fulfilled. So that's why this force of attraction exists between noble gases. And here again radius is equal to distance between noble gas 1 atom and second atom upon 2. Here we are not writing bond length. because it is only attraction. No bond is there. It is only attraction. So this distance is between the first atom and second atom of any noble gas, which is at the closest approach. They will not touch each other. They will be very near to each other. Okay. Why we are not considering when the boundaries are touching each other? When they will come in the contact of each other, children, they will repel each other due to nuclear charge. This positive and positive will repel each other. Okay, nucleus will repel. Okay, when they will come very near to each other, so there will be repulsion between the nucleus. That's why we are considering the closest approach. Then the force of attraction will develop. This force of attraction is called Vander Waal forces, and this distance between the nucleus of the two atoms is called Vander Waal radius. Here no bond is formed, and the radius will be distance between N1 and N2 upon 2. Okay. Third is done. Fourth is Ionic radius. You all know ionic means in the form of ion. It may be cation or maybe anion. Okay. So you can see that when cation is forming, that means there is loss of electron. Okay. Loss of electron is there, and positively charged ion is forming. Anion means negatively charged ion is forming by gain of electron. Okay. So you can conclude that. Suppose we are taking one example of sodium. Sodium is like this. Okay. And it is neutral. When it is losing electron, that means 281 will become 28. So one shell will be less in this, and this nucleus and valence shell distance will be less now, and this is Na plus. So you can say there is slightly decrease in the radius because one shell is removed from Na plus. Same here with chlorine. See here, this one is chlorine atom, neutral atom of chlorine, that is 287. When it is gaining electron, there will be slightly increase in the size of chloride ion, and this will be 288. Okay, so you can conclude that the size of cation is smaller than the size of anion, or you can write that anion or minus ion, then atom means neutral, then cation size is smallest among these three. Okay, this is the size of anion, atom, neutral atom, and cation. Sorry children, the size will goes like this: anion, that is minus ion, then atom, that is neutral, and then cation, that is positive charge ion. Okay, you can see that neutral atom is smaller than this anion, and cation is very small than anion. Let's take one example of chromium. Okay, chromium 3 plus and chromium 6 plus. Which one will be the smaller one? That will, the one which have more plus charge will be smaller. So you can say that 6 plus is smaller than Cr3 plus. Chromium 3 plus is larger in size and chromium 6 plus is small. More plus ion or more charge, the more smaller ion it is. Likewise, you can take Fe2 plus and Fe3 plus. More charge is here, so this will be smaller. Okay, and Fe2 plus will be larger than this. Okay, so like this you can conclude this ion size. Now you can conclude that the largest radius will be of Vander Waal radius, then it will be of metallic, then will be of covalent. Okay, because here it is overlapping, here it is touching of the edges, and here it is slightly gap in between two molecules. So this is the largest one, then this, and here it is overlapping, that's why it is smallest radius. Okay. Now variation of radius in period and group. Period means you are moving from left to right in the periodic table. So when you are moving from left to right, children, you will see that the nuclear charge is increasing and number of shell remains same. Suppose it is like this. So at the last you will see that the size is decreasing and nuclear charge is increasing. So in the period, radius will decrease. In the group, if you are moving down the group, the number of shell is increasing. So you can see that the radius is increasing. Okay, but here exception is also there. When you are moving in a period from left to right, this decrease of the size will be up to group number 17. But in group number 18, there is sudden increase in the size. Why there is sudden increase? See here, because Vander Waal radius is there, and this Vander Waal radius is for noble gases. So this radius will be more. So here there will be increase in the size of the atom for noble gases or group number 18. This is exception. Here when you are moving down in a group, number of shell is increasing. So there will be increase in the radius. But again one exception is there, that is lanthanide contraction. This you will learn in detail in class 12. But here you can say that lanthanide contraction is due to poor shielding effect. Poor shielding effect will do this lanthanide contraction, so that there will be not regular increase in the size of an atom. In few groups you will find that there will be very small or no change in the radius. For example, I am taking scandium, titanium, vanadium, okay, germanium, niobium, lanthanides. Then here you will find that these two have almost same radius. Why it is same? Because if you are moving down, the number of shell is increasing. So there will be increase in the radius, but in these cases the radius is almost same. Why it is same? Due to this lanthanide contraction or poor shielding effect of F subshell. Okay. Next term is isoelectronic ions. See children, iso means same, electronic means electron. So the ion in which same number of electron is there, these ions are known as isoelectronic. Or you can define it as the ions of different elements having same number of electrons in it. These are known as isoelectronic ions. You can say that isoelectronic radius decreases with the increase in nuclear charge. When nuclear charge is increasing, then isoelectronic radius, or you can say the radius of isoelectronic ion, they will decrease. Okay, let's take example N minus 3 O2 minus F minus Na plus Mg 2 plus Al 3 plus. Atomic number of nitrogen is 7. Okay, oxygen is 8, fluorine is, okay, this is the atomic number of nitrogen, oxygen, fluorine, sodium, magnesium and aluminium. Now for this ion, you can say that minus 3 means this nitrogen is gaining 3 electrons and now it has 10 electron. 8 will gain 2 electrons, now it has 10 electron. 9 is gaining 1 electron, so it has 10 electron. 11 is losing 1 electron, so again it has 10 electron. 12 is losing 2 electrons, so it has 10 electrons. 13 is losing 3 electrons, now it has 10 electrons. So you can see that they all have 10 electrons in it. Okay, if minus sign is there with ion, then you will add this sign with atomic number. So 7 minus 3 means plus 3 is 10. And when plus sign is there with the ion, then you will subtract that number. So 11 plus 1 is there, so you will write minus 1. Then you will get 10. Mg is 12, 2 plus is there, so you will subtract 2 minus. So 10 you will get like this. So you can see that they all have 10 electrons, so they are isoelectronic. Okay, isoelectronic ion. But you can see here that the nuclear charge, this atomic number is showing the nuclear charge also. Okay, so this nuclear charge is more. So when nuclear charge is more and they have to, suppose here nuclear charge is more, 13 is charged and they have to attract only 10 electrons. So they will attract 10 electrons very strongly towards itself. So the size of this ion which has more nuclear charge will be very small. Okay, why it is small? Because nuclear charge is 13 and 13 has to attract only 10 electrons. So more is nuclear charge and electron is less. So this will attract the electron more strongly toward itself. So the size will be small. Here you can see that nuclear charge is 7 and 7 has to attract 10 electrons toward itself. Okay, so nuclear charge is less and electrons are more. So here the attraction will be not that much strong. So you can say that the size of this is smaller, smallest, or the size of nitrogen is biggest among these given ions. One more time I am going to explain, children. First you will write the atomic number. Second, whatever gain or loss of electron is there. After that you will check they are isoelectronic or not. If they are isoelectronic, you will consider only nuclear charge. What you will consider? This nuclear charge. Okay, so if more nuclear charge is there and less electron is there, that means the size will be small because nucleus is attracting the electron toward itself very strongly. Okay, and due to this the size will be small. Okay, the size of ion will be small. And here the number of electron is more, nuclear charge is less. So the attraction will be not that much strong. That's why the size will be large or big and the attraction will be not very strong. Okay, nuclear charge will be not very strong. So here the size will be larger as compared to this Al3+. So whenever you are moving from left to right, the ions of these atom, you can say that the size is, this will be in like this. So I am writing it again. Okay, so N minus 3 will be the largest one, O2 minus, F minus Na plus Mg2 plus then Al3 plus. Okay, this will be in the opposite direction because here nuclear charge is more and electron is less. So this will be the smallest and this one will be the largest. Nitrogen is largest and aluminium is smallest. Now see, it is more visible here like this. Okay, nitrogen is largest ion and Al3 plus is smallest ion. Okay, that you can write it like this also.